better. Right. So what reaction is that? What type of reaction is that? If I'm adding an alkyl group to my base,
That's alkylation.
it's a Frida-Crafts alkylation. All right. And so the question now is, where's the alkyl group going to go? Right, it's secondary, so it's not going to rearrange, so we don't have to worry about that. But where is it going on the ring? That's the question. And how do we know? How can we predict where it's going to go on the ring? Is the oxygen attached to the ring a donor or an acceptor?
It'd be a donor.
It's a donor. It's got lone pairs. And so the product, you can predict it. It's going to be the alkyl group is going to add at the ortho position, and then it's going to also add at the para position. So that's my OH group, and I'm going to get a alkyl group on that position, plus I'm going to get one back here. Is that right? Because it's adding at this carbon right here. So that's the same carbon here and here. And this is ortho, and this is para. Anybody not see that? And again, we said that with a donor on the ring, that the ring is activated, right? So let's look at, let me show you why. And we can just show it through resonance. If I take this ring, right, can I do this? Sorry about that. Yes or no? Don't all speak out at once now. We don't want the Zoom to crash because everybody getting
Yes.
the right answer.
Yeah.
Yeah, that's it. That's the resonance form, right?
Yeah.
Which, but in doing the resonance form, what do you see? You see now that the ortho position is activated. Am I right?
Mm-hmm.
You can add an electrophile there. Right. And then if I drew the next resonance form, which I'll push this pair here and push this pair onto this carbon outside the ring. I'll just draw it in red. Is that right?
Yeah.
And so what? I'm not. I'm gonna put the charge where you can actually see it. So what does that mean for the para position right here? You see how it's got a pair of electrons on it. So you can also add an electron, not an electron, electrophile. Right, you can add an electrophile there too. So that's why the donors are considered activated groups, right? That you put them on the ring and they activate the ortho position as well as the para position. So they make them more reactive towards electrophiles. All right. Any questions about the activation, ortho, para, donors, acceptors, anything? All right, let's do one more example then. What's the product from that reaction? I'm gonna have a lot of editing to do on this video. What reaction is that? Let's go back up to the top. All the way back up to the top.
Halogenation.
It's a halogenation, right? We only talked about these three. Here, right? So it's a halogenation. We're adding a halogen. So the product is what?
Just replacing the bromine with one of the hydrogens.
Or replacing one of the hydrogens with bromine, right?
Yeah.
So this is the product. Just stick it right there. It's easy. What if I did another halogenation on that?
Wouldn't it be the same thing except on a with the different available hydrogen?
Mm-hmm. So the question is bromine a donor or an acceptor? And it's got 3 long pairs around it.
Is it a donor?
It is. We typically think about halogens being inductive electron withdrawing groups, but when they're attached to a benzene ring, they actually act as donors. So how many products am I going to get? If I have a donor on the ring, right? Donors are orthopara directors, and acceptors are meta directors. Is that right? Man, that's a good mnemonic. I need to use that. Dope in the morning. I can use that. Let me use that. Y'all catch that later. So this is gonna be one product. Is that right? And then this will be the other one. You're gonna get an ortho product and a para product. Are y'all following that or no?
Yes, you're saying if it's a donor, it's gonna have two products, and
Yeah.
if it's an acceptor, it's gonna have one product.
Yes. Yeah.
In the meta.
Mm-hmm. Acceptor is a meta director, and a donor is an ortho para director. All right. Any question? Any other questions? Because that's really it for these aromatics. We talked about the criteria for aromaticity. We talked about different reactions, nomenclature, as well as the directing effects. So there's really nothing else to cover on here other than to keep working problems. And what we'll probably do, since we're going to take this quiz I'm going to post it on Friday. What we'll probably do for the Friday class is I'll just have a bunch of examples and we'll just walk through them one by one.
Well, I thought we don't have class on Friday or Monday.
Yeah. Oh, yeah, that's right. We are the class. You're right. Oh.
Dr. Russell, can
Well,
you
it is
scroll
good
back
class.
down so I can take a screenshot?
Of the last page?
Yes.
All right.
Thank you.
Hold on. Let me zoom out so you can. This page right here?
Yes.
Mm-hmm.
Thank you.
All right. So we will have a study session tomorrow at 6.